Let's look back at the second problem on the exam that you took last week. And this was one of those double dippy problems where I was checking your mastery of a specific learning standard. It was 1x, so it was the standard that involved the order properties, the order axioms, and the upper and lower bounds, and suprema and infima, all that stuff that went into that learning standard. But I was also checking your mastery on 0a. How conversant are you working with quantified definitions, turning them around into a negation, and then structuring a proof of a quantified implication. So I'm kind of looking at two different things here. So when I assess this and give you your grades on it and your marks on it, it'll be broken out by those two different standards. But what I want for us all to think about for just a moment is what exactly am I asking you to do here? Because I have there's three different parts to this problem. The first asks you to finish the statement of the completeness axiom. So it just kind of gives you this shell of a statement for an axiom and asks you to fill in some blanks. So let's call that task number 1. I didn't label these on the exam sheet itself, so let's label them together here. So task number 1 asks you to finish the statement of this axiom. And then in task number 2, I'm asking you to take a statement, this statement right here, for all epsilon greater than 0, there exists an element x in epsilon, or x in e rather, such that m minus epsilon is less than x, and that's all predicated on e being a set of real numbers, which has a supremum, and we're calling that supremum m. Okay, so I'm giving you a statement, and then the next thing I'm doing is asking you to write the negation of this statement. So let's call that task number 2. And then part 2 of this problem actually asks you to do two things. It says either this statement here or this statement that you wrote here, because one is the negation of the other. That means that exactly one of those two statements is a true statement. Right? This is a principle of basic logic, right? Is that if I write down a statement and its negation, exactly one of those two statements will be true and the other one will be false. So what you're asked to do in this problem is, first of all, to decide which of these two statements is true. So I'm going to call that task number 3. So you have to look back at the two statements that you wrote and decide which one of them is true, which one of them is false. And then the fourth task on this problem is I'm asking you to write a proof of the relevant statement below. So there's kind of 4 different tasks that you have in this one problem. So there's a lot going on. And I want to start by just asking, of these 4 tasks, which one did you find required the least thought? Or which one taxed your brain the least? So in a quick show of hands, I think it was pretty even, like a 50-50 split. About half of you said that it was this first task here, finish the statement of the completeness axiom, that you thought was the easiest on your brain at the time. The other half thought that it was the second statement, write the negation of this statement using logical symbols. You thought it was either 1 or it was 2 that required the least amount of sort of mental horsepower in order to do. And almost nobody chose task number 3 or task number 4. So this is the first thing that Bloom's taxonomy surfaces, is a difference in what's sometimes called lower order thinking skills and higher order thinking skills. Lower order thinking skills are often things that are atomic, they're individual, they're things that kind of you can think about in their isolation, and it doesn't take a lot of mental energy to really kind of put things together. They kind of stand alone. They're individual thinking tasks. And higher order thinking skills are things where you have to pull from a lot of different regions of your memory and of your brain and a lot of different understandings and kind of bring a lot of different things together when you're doing higher order thinking. And so when I'm looking at the 4 tasks on this page, I would kind of see a difference between the tasks that you highlighted in numbers 1 and 2 versus the tasks that you didn't choose over here in 3 and 4. So this is one visualization of Bloom's taxonomy, and it identifies sort of 6 different thinking tasks or thinking skills that one might do in order to solve a problem or to write a critique, write an essay or whatever. There's a lot of different things involved here. And at the bottom of the pyramid, these first 3 layers are sometimes called the lower order thinking skills. Just because we call them lower order thinking skills doesn't mean that they're somehow not as good as. They still will require you to do quite a bit of thinking. See, they're sometimes called the LOTS, L-O-T-S. Lower order thinking skills, remembering, understanding, and applying. So at the bottom of the pyramid, we have remembering. So being able to find or remember information, such as make a list of something, name something, identify something, describe something, define something. And And then a step up from remembering is actually understanding and making sense out of information. So to be able to explain or to summarize or to interpret, that may require you to remember some stuff, but it also requires you to do probably a little bit more than just remember, right? You also might have to do some additional understanding work. And then a level up from that is applying. So being able to take the information that you now understand, what it means, and be able to bring that information into a new context. That's not totally new, it's probably similar to something you've seen, but it's not exactly something that you've done before, right? So this is something that's new, but it's still, you know, pretty much still within the playground where your understanding resides. So those three are often called the lower order thinking skills. Above the line, naturally then, are the higher order thinking skills. Higher order thinking. Naturally, these are sometimes called the HOTS, H-O-T-S. And that includes the ability to, sometimes, by the way, these are ranked on a spectrum as well, on levels going up. This particular diagram I like because it kind of puts them horizontally instead of vertically. So if you're applying a higher order thinking skill, you might be analyzing. So taking some information apart and looking for relationships between concepts that may not appear similar in the beginning, right? So being able to understand, for example, how maxes and mins relate to suprema and infima or something like that. So being able to relate across different contexts, different things that you might be looking at. Also to evaluate, to critically examine information and to make a judgment about something. So to be able to critique or to defend something or to make a judgment. Those are evaluative skills, and those are also thought of as higher order. And then finally, the creating skill, using all the information from here to create something that's new, something that's one of a kind, something that's yours. So to design something, to construct something, to invent something. So those three on the top are often thought of as the higher order thinking skills. The three on the bottom, thought of as the lower order thinking skills. So thinking about lower order and higher order thinking skills, where on this exam problem are the lower order thinking skills showing up, do you think? Which of these four tasks would you consider to be the lower order thinking skills? 1, 2, and you would even put 3 on that list? Let's take a look at them. So here's 1 and 2. Let's look at, first of all, at number 1. What kind of a statement is finish the statement of the completeness axiom by filling in these blanks? What are you doing? What kind of thinking? So task number 1, fill in these blanks to complete the definition. That's really a remembering skill, which on the diagram we saw a moment ago, that was the bottom of the pyramid. It's an inverted pyramid in our diagram, but it's sort of the most fundamental of the lower order thinking skills, to be able to retrieve a fact from your memory, right? And so I would call that definitely a lower order skill. If you remembered what this definition was, then chances are you did really well on this, right? You can just sort of go into your mental Rolodex, flip to this definition and say, oh yeah, there it is, right? So that I would call a lower order skill. What would you say is the task in number 2? Is that a remembering task? Is it understanding? Is it applying? Is it, or is it one of the higher order thinking skills? Yeah, I think I might agree with apply. So what exactly are you applying here?
How to negate a logical statement.
Yes, right. So you're applying something about logical statements and negations, something from 0A, right? The hidden learning standard that's woven throughout our course, right? It's understanding, so you have to remember, first of all, how to identify a logical content within a definition. You have to understand how negations work, right? That negations turn existential into universal and vice versa, and which pieces get negated and which pieces don't. So you have to understand how that all works. But then you have to apply your understanding to this particular statement, right? So that's the sense in which I would agree that this looks to me like an applying. So it's a little bit higher order on that Bloom's taxonomy, but it's still, you might still consider it to be a lower order skill. Let's look at task number 3. In task number 3, you have to look at 2 different statements. So you have to look at the first statement here, for all epsilon greater than 0, there exists an element, yada, yada, yada. And you have to look at your second statement, the statement that you wrote in the second question. So let's take a moment to just write that real quick. What do we write for the negation of the statement, for all epsilon greater than 0, there exists an x in E such that m minus epsilon is less than x? What is the negation of that statement? There exists an epsilon greater than 0. Then what? For all elements of E. And then what's the conclusion here? M minus epsilon is, yeah, there we want to negate that part of it. M minus epsilon is greater than or equal to x. So there's the negation of the statement up here. So once we finish this applying task, we now have two statements, right? For all epsilon, there exists an x such that m minus epsilon is less than x. The negation is there exists an epsilon such that for all x in E, m minus epsilon is greater than or equal to x. So there are the two statements, and then in task number 3, you're being asked to circle which one of these two statements is true. So what kind of a thinking task is that on Bloom's taxonomy? So remember, we had remembering, understanding, applying, and then we had being asked to choose between two statements, which one of those two statements is true. Which of these 6 things does it sound like we're doing?
Evaluating.
I think evaluating is probably the best match for what we're doing in that, right? So you have to look at each one of these two statements and then make a judgment, make an evaluative call, right? Which one of these two statements do you believe to be the true statement in this pair? So yeah, I would say the best match in Bloom's taxonomy for task number 3 is the evaluating task. And that would qualify then as a higher order thinking skill, evaluating. So there you probably had to stretch your brain a little bit more, right, in the moment, in the testing situation, right, to look at these two and say, all right, which one of these, we know exactly one of these two has to be true if one is the negation of the other, so which one is it? Right, so that's an evaluation call. And then once you've decided which one of these two is true, you circle one of them. By the way, which one of them did you circle? Was it the first statement or the second statement you decided was true? If m is the supremum of E, then is it true that for all epsilon greater than 0 there exists an x such that m minus epsilon is less than x? Is that true, or is its negation true? I want to decide from a quick diagram which one of these two statements is true. Maybe I'll just shade in a little portion of the real number line, and I'm going to call that my set E. We're asserting here that the supremum of E exists, and it's called m, so I'll just write that up here. M equals the supremum of E. And then let's follow Nicole's advice here, and let's look at the negation. And the negation says there exists an epsilon greater than 0 such that for all x in E, so every element in this shaded set, m minus epsilon is greater than or equal to x. So where would m minus epsilon be on this picture? Where would the number m minus epsilon live if epsilon is positive and m is here? Where am I going to find m minus epsilon? Well, it's definitely going to be to which side of m? It's going to be to the left side, because E is positive. That means that epsilon is positive. That means that m minus epsilon has to be less than m. So let's say m minus epsilon is here. Right? It's definitely to the left of m. And so if we assess this statement again, whatever this epsilon is, if this is true, then there's some epsilon such that when I subtract epsilon from m, all the elements of E are, if we look at it this way, m minus epsilon is greater than or equal to x. If we turn that around, we could say instead x is less than or equal to m minus epsilon. So this would be saying that all elements of my set are less than or equal to m minus epsilon. So in other words, we're saying then, if in the negation, we're saying that all of E is to the left of m minus epsilon. So that's what the negation would be saying. So now what do we think about that assertion? If I can move m down a little bit, and all of the set E is to the left of that new line, what do we think about that assertion? Intuition is that that's a false statement, because there's this little piece of the set E that is not to the left of that line. And now how do we know that there's a little piece of E here? How do we know that this wasn't just blank region of the number line? Definition of supremum, right. We said in the beginning that m was the supremum. It's the least upper bound. It's the least possible upper bound. Whereas if I nudge this down a little bit and the whole set is still to the left, then m was still an upper bound, but it wasn't the least upper bound, right? If this whole region here is empty. So again, that's how we might convince ourselves that this is a false, the negation is a false statement, and therefore the original statement might be true, right? So that's how I might develop some intuition. That's how I like to do it. Draw a little picture, figure out where stuff resides, and try and talk myself into some kind of contradiction. So that's tough. That's a challenging thing we just did. That was a higher order thinking process. We had to evaluate these two statements and decide which one of them we believe to be true. There is actually quite a bit of belief that goes on in doing novel mathematics, right? Mathematics research, even just learning a new topic for the first time. Mathematicians are not the cold logical bunch that you might think that we are. We often believe something is true long before we have a proof whether something is true. Or sometimes we believe something is true for a long time, and then it turns out that we find a counterexample, much later down the line. We find out that it's not true at all. But before we can write a proof, we have to decide what it is we're trying to prove. And that was this step, right? We had to evaluate these two things and make a call. And then after we evaluate, what is task number 4? Task number 4 is where you're asked to write a proof. Where do you think that falls in Bloom's taxonomy? Asked to write a proof. So you're asked to demonstrate, using the accepted logical conventions of our discipline, that a certain statement is consistent with the other facts that we know in mathematics. But that is fundamentally a creative process, right? You have to design the proof from the ground up. I haven't given you sort of a scaffold to fill in. I haven't given you a step-by-step or fill in the blanks or whatever. The whole thing is your architecture. And that makes it a creative process, I think. I would agree that task number 4, also definitely a higher order skill. I would call that the creating. So just this one problem on the exam is having you do a lot of different kinds of thinking at different orders, right? It's having you do some lower order thinking to do the remembering and the applying bits here at the beginning, and then we shift gears into the higher order thinking where you have to make a judgment between two statements on which one is true, and then you have to do the creative process of writing a proof. Sometimes when you see Bloom's taxonomy, those 3 top layers are also arranged vertically with analyzing and then evaluating and then creating. And anytime it's arranged vertically, creating always manages to be at the top of the pyramid for some reason. So I don't believe in layering those 3 the way that this diagram does, but those who do will often put creating at the very top of the pyramid, which is an indication that when you're asked to write a proof as a mathematician and a student of mathematics, you're doing something that's really at the top of the hill, right, as far as many people think about Bloom's taxonomy. And so if you're struggling with writing proof and discovering a proof and creating a proof, that's because it's fundamentally one of the highest order thinking skills that mathematicians do, right? And so that's the right struggle. That's the struggle that I want you to be having in this course. The struggles that I want you to have less of are the struggles down here towards the bottom, right? Remembering a definition, being able to pull it out of your memory bank and reproduce it on a page. Understanding kind of what a definition is actually saying, being able to summarize it in your own words and use careful language. Applying a definition or applying a theorem to a specific example. Those are the things that you want to have those in your pocket so that when it comes time to do these higher order skills, that you don't have to spend your mental energy down here, that you can spend your mental focus working on the higher order skills. So this is, now that we've had this discussion, this may be a bit of a red herring question, but I'm going to ask it anyway. So when you learn math in high school, let's say you're taking Algebra 2 or pre-calculus or something like that, where on this taxonomy do you feel like in order to make good grades in a pre-calculus class in high school, where were you most of the time on this taxonomy? Applying. So you probably had to do some applying, but being able to shift a graph to the right by applying the principles, understanding how to shift a graph and remembering the formulas for it. So applying, sure. Everyone agree with that, or would somebody want to make another suggestion? High school math classes, where did you live mostly on this? Yeah, probably level 3, level 2, level 3. Yeah, right. That tends to be when college students get asked this question. That tends to be the most frequent responses. Somewhere around 2 or 3. In order to make an A in a high school math class, you just have to be able to apply everything. And then comes college. and then here we are in a senior level course in college. And based on the conversation that we've just had, where do you want to be in order to make an A in real analysis? probably a little higher than that 3, right? Probably a lot of what you're really doing to make your bones in this class is up here in the higher order thinking skills. Are you able to analyze and make judgments and to create things? And that doesn't mean that the lower order thinking skills are less important. They're maybe more important than ever because you have to build upon them, use them as a foundation to get to those higher order skills.